Okay, let's get this 3D geometry out of Fusion and into a format that you can bring to any 3D print preparation software. We're going to print a lot of these parts, but we're not going to print all of them. We're not going to print this 1/4-20 machine screw and the lock nut. We're not going to 3D print these 832 machine screws and their corresponding hex nuts. And we're not going to 3D print these tiny little 440 screws down here on the collar clamp at the bottom of the weight cup. We're also not going to 3D print this 36-inch long 1/4-inch wooden dowel rod. We're just going to get all that stuff at the hardware store and we're going to move on with our lives. It's not worth it to try to 3D print everything, and it often makes no sense. 3D printing is an excellent technology for some solutions, and we're going to prioritize those. Great. Let's export the rest for 3D printing. But how? Well, look at this pulley. If I select it and find it in the project hierarchy, I can find that it is called pulley. And if I open up my data panel, I can find where it came from, the pulley file. I could open this up and export from here by going to the File menu and selecting 3D Print, setting my preparation type to export, and then selecting the pulley as the object that I want to export, making sure my format is set to STL binary, the standard triangle library that will work with any 3D print prep software, making sure my unit type is correct, and I'm going to be using a Bamboo Lab X1C printer, so I'm going to use millimeters because that's what that tool expects. And the rest I'm just going to leave alone. I'm going to click OK, and I am going to allow this file to be exported out of Fusion onto my computer's downloads folder. And I'm going to notice that its name is correct, Escapement Pulley, so that I can find it more easily when I have a pile of these STL files in that downloads folder. Click Save, and there it is in the downloads folder. Great. I can export this way, but I can also export straight from the assembly file. The process is the same: File, 3D Print, and then select the object you want to export, and just click on it right there in the assembly file. When you've got a lot of parts to export, this is the expeditious manner in which to do so. So let's do it. We need one of each kind of part. There are 2 pulleys in this assembly, but we only need to export one of them. We will duplicate to the right quantity when we're at the print prep software. So work your way through all the parts until you have one of each in your downloads folder. And if any of the parts still have their default name, like this one, Body 1, go ahead and name it descriptively. This is the weight cup, so I'm going to name it Weight Cup. It's so easy to get confused if you don't take a moment to name your files. Here's what I ended up with, and you should have the same. And you could study this list, or you could just look at the assembly and ask, did I get one of each kind of part that I'm not going to buy at the hardware store? Good. We have exported STLs. It's worth noting at this point that the moment you export an STL, you are triangulating your mesh. You are turning your 3D geometry into a bunch of triangles that approximate the shape of that 3D geometry. They do not perfectly represent it. The huge win, the reason to export as STLs, is that it allows us to import those files into our 3D print software. The downside is that we've essentially downgraded our model into something much harder to make edits to in the future. So keep this in mind. You want a workspace where your parts are perfect. That's Fusion, where you can edit the geometry in its perfectly defined geometric state. And you need a mechanism for exporting out of that tool into the variety of 3D printer options on the market. So in Fusion, click Upload, and bring one of those STLs, the 60-toothed gear, back into Fusion to see the difference. Open up the STL version, the Escapement Gear 60 Teeth, and then also open up the Fusion file, Gear 60 Teeth. Notice how with Gear 60 Teeth, the Fusion file, with the Select tool, I can select all the different components of the gear. The top face, this arc between 2 of the teeth of the gear, this arcing face that runs down to the bottom of the gear. But with the STL file, notice the messiness of all these somewhat randomly arranged triangles trying to approximate this shape. I can no longer select any individual components. I can only select the entire object or nothing at all. So use Fusion for creating, editing, modifying geometry in a perfectly geometric way, and use the STL file format for getting out of Fusion and over to the 3D printer, because that's what we're doing next.